we present Haptic Bots, a novel encounter-type haptic approach for virtual reality based on tabletop, shape-changing swarm robots. Currently, in VR applications, users cannot physically interact with, touch, or grab the virtual objects. With Haptic Bots, we aim to remove this barrier. Haptic Bots addresses this issue through modular, fingertip-scale robots that move on a tabletop and change their height and orientation to haptically render various surfaces of virtual objects on demand. By using these robots, we increase deployability, scalability, and generalizability. Through two real systems, we can raise and lower the platform, as well as provide a very solid surface capable of carrying weights of up to 2 kilograms. Their fast reaction time, speeds reaching 24 centimeters per second, and their spatial accuracy allows the robots to render continuous surfaces. Their strengths make Haptic Bots ideal for haptic rendering of encounter-type VR objects. We combine Haptic Bots with real-time hand tracking in VR. Users can grab, push, or touch the robots, and the robots can travel to encounter the finger of the user, or follow the finger through a continuous surface, as well as coordinate with other robots. We performed a user study to evaluate both the encounter object performance as well as the continuous shape perception. Haptic Bots outperformed static pin-based shape displays in regards to continuity perception, while providing similar accuracy in a tilt and shape recognition task. Haptic Bots can have many future applications, including remote collaboration, education and training, design and 3D modeling, and gaming and entertainment.